let's revisit the idea of net area. First of all, let's consider the function f of x equals sine x on 0 to 2 pi. And I want to find the area under the curve. Well, sine x is continuous everywhere, so there's now not a continuity issue. So right away you go from 0 to 2 pi sine x dx. The antiderivative will be negative cosine, because derivative cosine is negative sine, so I need that double negative there. And I'm going to evaluate this from 0 to 2 pi. So this is going to be the negative of cosine of 2x, which is, I'm sorry, not 2x, 2 pi. That's cosine of 2 pi minus cosine of 0. And this is going to be a negative of, this is a negative 1. This is a minus 1. Oops, 2 pi is 1, not negative 1, sorry. 0 is 1, but it's negative because of that. 1 minus 1 is 0, so this is just 0. Well, what's up with that? Well, now we're back to the idea of net area. If I go ahead and draw this out from 0 to 2 pi, sine looks like this. When I integrate, this will give me a positive contribution. This will give me a negative contribution between 0 and 2 pi. And this is actually, these two areas are, absolute values of these areas are the same. So when I add these things up, they cancel each other out. So if I really want to know the total area between the curve, what I just found was that the net area was 0. But again, if I want the total area under the curve, I need to find this point right there. And I need to break this integral up. I need to integrate this as part 1. I need to integrate this as part 2. And I need to take the negative of this to give me my total area. Well, what I need to find is when is sine of x equal to 0, because it's 0 here, here, and here. Well, sine x equals 0, specifically on 0 to 2 pi. That means that x equals 0, pi, and 2 pi. So this value right here must be pi. So what I can do is take the integral from 0 to pi of sine x dx plus the integral from pi to 2 pi of sine x dx. But remember, we said the second piece right here gives me a negative contribution. So rather than adding, I'm going to subtract. So what I'm going to have is a double negative. That's the same idea as I could just write plus and take the absolute value of this whole thing. It's the exact same idea. So when I start working this out, I will get negative cosine of x evaluated from 0 to pi minus a negative cosine of x from pi to 2 pi. And now all I need to do is evaluate this thing. And I'm going to end up with a negative of this first piece. Cosine of pi is a negative 1, so it's a negative 1 minus cosine of 0. That's minus another 1. So that's negative 2, negative of a negative 2, so that's going to be 2. So the area here is 2. And right away, because of symmetry, I know this area is going to be 2 also. And when I evaluate this, and I'm going to let you finish this up numerically, but that's exactly what I'm going to find. I'm going to end up adding 2 to it. So this total area is simply 4. So based on sine x between 0 and 2 pi, first I calculated the net area and said that the net area was 0. And then I calculated the actual area between the curve and the x-axis, and the actual area is going to be 4.